Assalamu alaikum. In our last lecture, we stopped here where I gave you an example, curriculum, to solve it, to try it at your home, to see if you can like guess the structures or not. It's completely fine. If you are unable to solve it, completely fine. But just it was a concept of like to see if you were actually like trying to solve it by yourself or not. It's completely fine. The participation matters. Being able to solve it doesn't matter because we learn from making mistakes. Okay, so in this example, you could say that intentionally or unintentionally, some information was actually left behind. So there are some informations to be given. Now, what are the informations? At first, it is being said that the curriculum, sorry, not curriculums, what's the name? Curcumin. So this curcumin, then this molecule A and this molecule D, they all tend to react with 2-DNPH. Curcumin A and D reacts with 2,4, sorry, not 2-DNPH, it should be 2,4-DNPH, 2,4-DNPH, DNPH. Now, what is DNPH? It's from AS contents, which is dinitrophenyl hydrazine. So 2,4-dinitrophenyl hydrazine. It's just a reagent which reacts with some sort of molecule. I would urge you to pause the video and just go back to AS contents and just see what 2,4-DNPH does and where is it used. Now, AB reacts with sodium carbonate, Na2CO3. Lastly, we have, what do we have? Do we have any other information? No, we don't actually have any other information. Okay, so I hope you have done it. You have gone to the AS contents and observed what sort of molecule or what does it do. So 2,4-DNPH, it's basically used to identify the carbonyl compounds. Let me just a moment. Let me just grab the contents from AS as well to say what does 2,4-DNPH do, just in a brief introduction. So yeah, so basically we tend to identify the carbonyl compounds. Okay, so carbonyl compounds are what? Those are aldehyde and ketone. These two molecules both tend to react with what? Our 2,4-DNPH. Now let's see. Let's try to solve it. If with this given information, like now I would urge you to pause the video again, and with this given information, try to solve the question again. Okay, try to solve the question again. Even if you can't solve, then completely fine. It's we'll be solving together now. Now, yeah, let's see. We shall proceed with our informations given. Let's see, what do we have now? It says about A, B, but there are not much of information A, B. Let's see what else can we find. From here, they're saying when we react ACN plus NaCN, we get this one. Now we do know that this is what type of reaction. This is sort of displacement reaction happening because cyanide ion is like being included. See, oxygens, like here we have this 2 mole of oxygen and like new 2 mole of nitrogen is here. Here, sorry, new two atoms of hydrogen is included here, but here it has no hydrogen atom. Moreover, here we have 4 hydrogen atoms, but here we have how many? 6 hydrogen atoms. That means here's what is happening here actually. It's actually reduction is happening. Reduction is what? Gain of hydrogen. So that is what happening. So if this is the possible case, and we know from our AS contents that whenever cyanide I'm sorry, HCN reacts with KCN, we get this product. So this is direct like contents from AS. So we get this product, which is our how do I draw it? So basically, it should be, this is an oxygen. This is the oxygen here. We have 1, 2, 3. So 1, 2, 3, 5. Okay, 5 more carbon is going to get added here. So if that's the case, then wait. Okay, so this is this part, and there's this hydrogen here. So this hydrogen is going to get eliminated because now we have this amine or CN, like CN here. If that's the case, then this should be wait, OH. I guess this should be the situation then, and this also should be the situation. If it defines, let's see, does it actually happen like this? 2 hydrogen, 4 hydrogen, 6 hydrogen. That's 6 hydrogen is there, 2 oxygen is there, 3, 4, 5, 5 carbon is there, and 2 nitrogen. Okay, so that means this is actually our structure. Now, cyanide, hydrogen cyanide with NaCN causes this sort of reaction to happen. See, like from keto, from aldehyde, we had this aldehyde previously here, CHA group. From there, alcohol is being regenerated. That means what? If from alcohol to aldehyde is what? Oxidation reaction. Then the reverse is what? Reduction reaction, obviously, isn't it? So this is the reduction reaction happening. At the same time, cyanide is also being added. Okay. Now, this is our C, like the molecule C, we could say. But so far, whatever information is given, we could say this is our C. Now let's see, what else do we have? We have B here. Okay, but nothing is given about the condition of B, like what will react with C to form B. But one information is given is B reacts with sodium carbonate and B reacts with no. So so only B reacts with sodium carbonate. That means sodium carbonate reacts with whom? Like which sort of molecule? Acids, isn't it? So that means there must be an acid, because acid plus metal carbonate reacts, forming carbon dioxide and salt of the acid and water vapor, isn't it? Now, let's see what can be done here. What is the difference at first? Let's see. Here we don't have any more nitrogens here. Okay, that means nitrogen disappeared. We have 8 hydrogen in this case, and we have 6 oxygen. So is it possible to make such a molecule? Let's see. We have, let's say, this carboxylic acid, like alcohol here. If we oxidize them, is it possible to form carboxylic acid? Yes, it is possible to form carboxylic acid in each of the cases. Now, how to reduce this nitrogen from here? In order to reduce nitrogen, what could be done is, this is actually a nitrile compound. So we could do hydrolysis of nitriles. Hydrolysis of nitriles is done. Let's see. Then CH2 is here, and we have C and C. From here, there's okay. So here actually carboxylic acid won't be able to form. Why? See, this is not a primary alcohol. Why? Because where we have only 1 hydrogen, okay, and 2 like alkyl group. This is also, you can consider in this situation with respect to this part, we can consider all the others are what? Carbonyl compounds. No, since, sorry, all the others are alkyl groups. This is also alkyl group, this is also alkyl group, okay? we can consider that. And this is only one hydrogen, and according to the rule, for like if the oxygen containing carbon has only one hydrogen bonded with it, like this carbon, if it is bonded with only one hydrogen, then that is a primary alcohol. This is a primary alcohol. That means, sorry, this is a secondary. I'm really sorry. Carbon containing OH group, if it is bonded with one hydrogen or two alkyl groups, so either of them, one hydrogen or two alkyl groups, then this is a secondary alcohol. Since this is a secondary alcohol, that means doing oxidation won't form any carboxylic acid, rather it will form a ketone here. So if that is the case, that means that satisfies our like information or definition for like the molecular formula being given to us. Now, the molecular formula given to us, there are 6 oxygen. So if we oxidize this forms one like C double bond O, that means a ketone is formed. Also here a ketone is formed, because here is also the same pattern follows. Now about the cyanide, if we do acidic hydrolysis, we can get a carboxylic acid here. Okay. Also for this part, if we do acidic hydrolysis in this situation, we could get a carboxylic acid here. Now let's see if it matches our situation or not. We have 5 carbons, 1, 2, 3, 4, 5. We have 4, 1, 2, 3, 4, 5, 6, 6 oxygen, but we have 1, 2, 3, 4, 4 hydrogens. So what else could be done here? Let's see. If any situation happens that this ketone actually didn't form, because what we did here, we have to apply only one condition, isn't it? Only one possible condition could be applied here. That means what? If hydrolysis is done, then alcohol won't be affected. Alcohol will remain what it was, isn't it? So in this situation also, alcohol would remain what it was. Why? Because we didn't do oxidation here. Like if cyanide does not go undergo oxidation reaction, so we did not do any oxidation. Okay, no oxidation was done here. So like even if we try to do oxidation, this one won't be formed. Rather, alcohol will be changed to ketone. But if we do hydrolysis, cyanide will transform into carboxylic acid, but our alcohol will be neutral, will undergo no reaction. That means what? Hydrolysis is causing CN to get transferred to COOH, but nothing to the OH group present. Okay, but oxidation is doing what? Is converting OH to ketone, but nothing happens to carboxylic acid. Sorry, cyanide. Nothing happens to our cyanide group. If that is the situation, that means what? Either of the reaction could be possible. Now, doing hydrolysis is much more feasible. Why? It fulfills our molecular formula. Here we have carboxylic acid. Here we have carboxylic acid. Now, 2 oxygen, 4, 5, 6. We have 6 oxygen there. We have 1, 2, 3, 4, 5 carbon here, and 2, 4, 5, 6, 7, 8, 9. Now we have 9 hydrogen. No. 2, 4, 2, 3, 4, 5, 6, 7. Yeah, 8 hydrogen here. So that means this is our molecule of the compound B. So this is our compound B. So we have found our compound B in this case. Now let's see what else can we do. From B, like they said, we get B from A. Okay, we get B from A. And they have given us that we have 4 hydrogen, 6 oxygen, 5 carbon. That means carbon number string and oxygen number remains same. Hydrogen is now less. Now this could be a possibility that this is actually a ketone, the molecule is initially drawn. Why? Because if ketone was here, that means what? The 2 hydrogen will disappear. That means if we have total 8 hydrogen, if 2 from each side disappears, that means what? In total 4 disappear. That means 8 minus 4 is what? 4. That means this is a possible character or a possible compound. That means let's see, CH2 and C ketone Here's C ketone. We have carboxylic acid here. We also have carboxylic acid here. Let's see now, 1, 2, 3, 4, 5. 5 carbon is there. 5 carbon is there, isn't it? Yes, we have 5 carbons. We have 1, 2, 3, 4, 4 hydrogen. 4 hydrogen there, and 1, 2, 3, 4, 5, 6, 6 oxygen. Yes. So we are actually done with it. So let's see actually. Yes, our information also satisfies. See, it said curcumin A and D reacts with 2,4-DNPH. 2,4-DNPH means what? It like the compound should contain, like if it reacts with 2,4-DNPH, that means the compound should contain a carbonyl compound. Sorry, carbonyl compound. Now, carbonyl compounds are whom? Aldehyde and ketone. And we do have a carbonyl here. That means it satisfies our information. Also, it says this molecule A should react with sodium carbonate. That means what? It must be acidic. See, we have a carboxylic acid group here. At least actually 2 carboxylic acid groups. That means this actually satisfies our information requirements. Now, what are we left with? We are left with component D. They said D must also contain an aldehyde because it said it should react with 2,4-DNPH. Now, there must be an aldehyde. Okay, fine. Then from here, if we add I2 plus OH minus and H plus, that means it is undergoing iodoformation reaction. Now, in iodoformation reaction, what happens? I would urge you to go back to your AS contents where to find the iodoformation reaction part. There you see that in order to find iodoformation reaction, what happens? Try to pause the video and go through the notes of the iodoformation reaction from AS contents, then come back to the session. Now, in iodoformation reaction, we know that we need either of these two groups, COCH3. Either this group is needed or OHCH3H, this group is needed. Okay, if alcohol is present, then this group, or if ketone or aldehyde is present, then this group is needed. Okay, now what happens when this is actually like doing the reaction, undergoing the reaction? This CH3 breaks. Okay, this CH3, this portion, it breaks, forming what? This portion, after it is broken, it forms CI3 by replacing each of the hydrogen. Okay, and wait, let's see. Sorry, this is actually CHI3. Yeah, CHI3 will be formed. CHI3. Now, why this H? Because after it's broken, it forms this methane, CH4. From that methane, 3 hydrogen disappears, forming like replacing it with iodine, and we get CHI3, which is actually the iodoforms part. Okay, the yellow, the iodoforms main component there. Then we have the rest of the molecules, whatever it is. So that rest of the molecule, if there was, let's say, for the rest of the molecule, what will happen is this portion. Okay, let me show it in a different part. Let's say this is our alkyl group. Okay, and this is some sort of, let's say, some CH3, CH2, CH2. Okay, then when iodoformation reaction happens, this portion breaks up, CH4 is formed, and we have CO, CH2, CH3, and here this molecule, it actually forms, let's say, this aldehyde, and further it undergoes oxidation reaction. From here, this will form this OH, CH2, CH3. Now, since we have added here what? We have added here alkali at first. That means what? Salt of the carboxylic acid will form. Let's say the alkali is in this case given NaOH. Okay, that means what? This acid, it will react with this part, and Na plus O minus and we'll be having this part, this molecule. Okay. Finally, we also added a second condition, which is H plus. That means we acidified it, and we know when we acidify it, what happens? The salt disappears and carboxylic acid is regenerated. CH2, CH3, sorry, CH2, yes. So this is another part, okay? And the rest of the products are there, like NaI, or like salt of the halide and the metal from this like alkali. But since nothing is given like here in the like above example, then we can just simply consider that only I minus is generated, and we have water as well, water being formed. So these are the 4 products forms. Okay, from CH4, I forgot to mention, from CH4, CH remains and I3, like 3 hydrogen disappears, replacing them with iodine. So this is the one of the product, this is another product, this is another product, and finally we have this or this as the other product. That's mean 4 total. Total 4 products are formed. Up above one or less, the below one. So in total, 4 products are being formed. Now, that means it undergoes oxidation, iodoformation reaction. After iodoformation reaction, it produces this molecule. Now, can you guess actually which of the 4 product is this one? Obviously, this is not this part. This is not obviously the CHI3 part, isn't it? Obviously not, because that will be identical to this one, but not that one form. This is also not the iodide which will be formed. Like if sodium hydroxide was provided, then NaI would have been formed. But from there, this is not the I minus part, isn't it? Like this is not actually that part. And then we have what? We have water, but water is also not generated. Finally, we have what? We have the largest molecule. That means this is actually the largest molecule being formed. So if this is the largest molecule formed, that means we must also have what? We must also have CH4 group or CH3 group. Now at first C, using this condition where actually a carboxylic acid is generated, because that's our ultimate thing which happened, isn't it? See, when we added H plus here, carboxylic acid regenerated. So that means we need to find the carboxylic acid portion. Now, which of this portion is carboxylic acid? Is this one? No. This is actually, we could say, this is a ketone actually, isn't it? Oh no, this is not a ketone, this is an ether. This is this group, C, and we have this H3, and then there's this oxygen and this bonded with the benzene carbon. So this is the ether group. So this is not the product we are looking for, or the group we are looking for. Then we have this OH alcohol, but alcohol we are not also looking for. And finally, we have this carboxylic acid. That means this is actually the portion where that double bond or carbo, you can say either alcohol group or our aldehyde or ketone group or carbonyl group was present here. Now let's see how many hydrogens, carbons do we have. We have 1, 2, 3, 4, 5, 6, 7, 8 carbon. That means yes, that was the CH3 group present there as well, because 9 carbon should be there. Then we have 10 hydrogen. So 10 hydrogens. That means wait, if this was, let's say, let me draw it in that place. Let's say this is our that benzene structure. We have a H3CO group here. We have a OH group here, and we have a carboxylic acid. So instead of carboxylic acid, if we are forming that group, so OCH2. This is one possibility, and the possibility instead of this one, we should have what? We can have. Let's draw it again. CH3OH. We can have alcohol group here. So O, H, H, and CH3, either of them. Now let's see which one is possible here. We have 9 carbons. So is it 9 carbon? 1, 2, 3, 4, 5, 6, 7, 8, 9. And here also 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 carbon in both the cases. Then we have how many hydrogens? Let's see. We have here, where did it go? Yeah, we have here 10 hydrogens. So let's see. Here 1, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's so far good. But is it here 10 as well? 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we have 12. That means alcohol is not the molecule we're looking for. Rather, we're looking for actually the ketone, or like this portion here. So this is a ketone as well. Like specifically, this is actually a ketone molecule. And how many oxygen did we have? 3 oxygen. So 1, 2, 3. That means it satisfies our requirement. So we have also found our molecule G. Now what else are we needed to find? We needed to find curcumin. Now curcumin, let's see. You have to notice one thing very carefully here. Curcumin, when it is heated with acidified KMnO4, it produces 1 mole of this one, it is said, and 2 mole of this one. That means this is like 2 such molecule is going to be there, and 1 molecule is going to be there. With that, this curcumin is going to be formed. Like curcumin contains 2 molecules from this part and 1 molecule from this part. Okay. Now let's see. And remember, hot acidified KMnO4. This is separate. Like this is actually what is it doing? This is breaking a molecule into 2 portions. That means what? This is actually, we know, oxidizing agent. Now oxidizing agent, if alcohol or aldehyde is there, if aldehyde or alcohol is there, let's say, then adding KMnO4, it does not break any molecule, rather it oxidizes the molecule. But curcumin, when KMnO4 is added, it is breaking as well as oxidizing the molecule. That means what? Curcumin does have double bonds. Remember, alkene undergoes this sort of reaction. So from that part, let's actually try to visualize our component. We have this molecule here. OCH3, OH, CO, CH3, and we have our molecule A, which is in this case CH2, CH, no, this is C double bond O, COOH, C double bond O, COOH. So these are the 2, like this is the molecules here. This should be 2 of them, and they should be 1 only. Now, the molecular formula of curcumin is given C21H20O6. Now, how can we make them together to form such a molecule? Let's see. What are the products usually formed when we add hot common of KMnO4 to double bond? Usually these 2 are formed, which is if we have carbon containing the group, the double bond 2H, that means carbon dioxide will be formed here. If, however, we have 1 hydrogen, 1 alkyl group, that means what? Carboxylic acid will be formed. But if we have both alkyl group, then what? Ketone will be formed. So we need, like, obviously here carbon dioxide does not exist. Like this is, neither of them are carbon dioxide. That means we have to look for carboxylic acid and aldehyde or ketone. Sorry, ketone. Carboxylic acid and ketone we have to look for. So here we have a ketone here, and here we have carboxylic acid as well as ketone here. We have to see which one of them actually could be formed by breaking the molecule. Now, this one has in total 3 oxygen, and this one has 6 oxygen in total. But our curcumin must have 6 oxygen. Now, 2 of such molecules means what? 2 times 3 oxygen, which is 6 oxygen here, and here we have 6 oxygen. That means in total 12 oxygen is there present, but we need only 6. That means half of this oxygen. That means half of the oxygen should have been disappeared. Let's see. Obviously, the molecule from here is going to be this part, which is in the double bond. Why? Because neither of, like, other than that, none of them actually have a ketone or carboxylic acid group. So we are pretty much sure this should be our group that should be bonded with or forming double bond. So let's draw the part. Let's say this is our OCH3. We have OH, and here we have, let's say, this is our, let's say, the CH3 group, and this is our double bonds part. Okay, we have like drawn just the double bond part here. The oxygen disappeared. Fine. So 2 oxygen actually disappeared actually for 2 of the molecule. That means we are left with 10 oxygen. That means 4 more to go. 4 more to go means if we replace each of this oxygen, like each of the, if this ketone actually was supposed to be in the reaction, that means only 2 oxygen would have been disappeared, but we need to remove what? 4 oxygen. That means this cannot be the case. But if this was carboxylic acid part, then 4 oxygen will be disappeared. 2 from here, 2 from here. That means what? It is a possibility that that was the portion for the carboxylic acid. And C, our information also gives us the idea that A is dinitrophenyl hydrazine. Okay, curcumin. Yeah, sorry, not A. Curcumin is a molecule which reacts with 2,4-DNPH. That means it reacts with dinitrophenyl hydrazine. That means it must contain our ketone group. Now, obviously, if we remove this ketone group, okay, and if we keep the carboxylic acid group, then what will happen? There are no more carbonyl compound remains in curcumin. Why? Let's see. Let's say this is the molecule, and we form this portion, which is the ketones part, and we have, let's say, this is the CH2. This is the other carbon double bond, and here we have a carboxylic acid, and here we have a carboxylic acid, and here is the portion, let's say, the other way, because 2 mole was there. So we have CH3, and we have the exact same molecule having a mirror image, CH3 OH. Okay, now see, here we don't have any ketone group. That means this molecule is unable to react with our 2,4-DNPH. At the same time, this molecule does not like satisfy our number of carbon, hydrogen, and oxygen. See, we have 1, 2, 3, 4, 5, 6 carbon, 7 carbon, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 carbon. 23 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 23 carbon. Am I making some mistakes here? No, it is perfectly fine. Then I guess I gave a most probably, just a minute, let me see. 1, 2, 3, 4, 5, 6. Oh, yeah, I made a mistake here. This is actually what? This is actually, it was D. I like picked up the wrong one. Like the molecule we drew here, this is actually what? This is actually D. But from like breaking curcumin, D wasn't formed. Breaking curcumin, this carboxylic acid portion was formed, isn't it? So we actually picked the wrong one. That shouldn't be the ketones part. Like that, we actually took the ketone, like, yeah, the ketone here. So this is actually this molecule, you could say. This should be actually. So COOH should be here. Okay, yeah, because that's what they have given us. That means here it actually contained a hydrogen here. But even though, does it fulfill our requirement? Let's see. Now we have 2 less carbon, that means 21 carbons are there. What else do we have? We have, let's count the number of hydrogen: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 hydrogens are there. Okay, that's fine. But what about oxygen? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 oxygens here. Though the hydrogen number, carbon number remains same, but oxygens are more here. At the same time, we don't have any ketone group here. Since we don't have any ketone group here, it is not going to react with 2,4-DNPase. That means this is a wrong molecule. That means here, instead of this ketone, this carboxylic acid should have been taken part in the reaction, in the formation of the bond. That means this portion should be forming the bond. Let's see. We have CH2. Okay, then we have this ketones part. And finally, we have this carboxylic acid, let's say C. And we have this, let's say, double bond and hydrogen here. C double bond and hydrogens here. Okay, and we have this, let's say, this benzene part. Also, the benzene part also has a hydrogen here. And we have OCH3. And then we have OH. And from here also we have CH. Wait. So we have OCH3 and OH here. Let's see now. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 carbons are there, C21. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So H20. We have 1, 2, 3, 1, 2, 3, 4, 5, 6. In total, 6 oxygen. At the same time, this is a ketone group here, which is going to react with our 2,4-DNPase. Hence, this is actually our curcumin. Okay, that means it satisfied our information, and hence we are done with our curcumin part. Now let's move on to the next portion. Actually, the second part of the video should contain the next portion. So yeah,